I'm going to show you 3 ways to read information from the serial monitor, how to do something useful with that information, and we're going to do this at 3 levels of complexity. In this video, we're going to be communicating with our chosen microcontroller via USB. I'll be using an Arduino Uno, but you can follow along with almost any microcontroller. Many microcontroller boards will have a USB to UART converter, and this allows us to send information from the serial monitor over USB to the microcontroller board and have it interpreted as serial data. On authentic Arduino Unos and some of the higher quality clones, this is done with an 18 mega 16U. And I'll show you where that is now on this one. So on the Arduino Uno, it's here, this guy. Many of the Uno clones use a chip called the CH40. That's this guy here. And we can also see that I've got a nano here. That's it here on the underside where they're normally mounted. And most of the ESP32 boards use a CP2102, and that is right here. The first way we're going to look at is the most basic way. It's not very useful, but it's a good demonstration to understand what's going on. In the setup, the first thing we're going to do is create a serial class with serial begin. Inside, we're going to put 9600. This is the baud, and it's the speed at which we communicate, measured in bits per second. Then in the main loop, we're just going to check the serial line with serial.available, and if there are any bytes available in the serial buffer, we'll read them with serial.read and then send the response straight back to the terminal with serial write. This will give us some feedback and let us know that what we're sending is actually being read. So let's send a message from the serial monitor to the Arduino and see how we get on. So we're going to want to just make sure that we're connected to the Arduino Uno and that we're on the correct comm line. Then we can upload the program to the Arduino Uno. Once that's finished uploading, we can go up to our serial monitor here, making sure that we're on the correct baud, which is 9600 and 9600 here. And now we're just going to enter a message that we want sent back to us. I'm just going to type in hello world and press enter, and we should see hello world back. Perfect. Now I'm just going to put in a couple of numbers and same again, press enter, and yeah, we get them back too. Now we've seen that we can send data from the serial monitor to the Arduino and it's relayed that same information back to us. We're now going to start introducing a little bit more functionality into the code in our second way. Specifically, we're going to send commands to turn the onboard LED on and off, which is this blinking one here. Firstly, we're going to need to be able to store the data that is being sent from the serial monitor. To do that, we're going to create a string called command. In the setup, we're going to set the pin mode for the onboard LED to output. And this time when we're checking the serial monitor, instead of reading byte by byte, we're going to use the function readStringUntil. This function reads information from the serial buffer until it finds the specified termination character. In this case, we'll use the new line character. The function then returns a string, which we're going to pass to our command string. We're then going to compare our command string to a predefined string LED on using the string function equals. And this function returns true if the strings are equal, otherwise it returns false. Okay, so if our command string is equal to LED on, we're going to print back to the serial monitor turning on, followed by setting the digital pin that controls the LED high. Okay, now so let's now use an else if to compare our command string with LED off. And predictably, if they are equal, we'll print to the serial monitor turning off and then turn off the LED by setting it low. Finally, we're going to use an else statement as a form of troubleshooting. If the command string didn't equal LED on or LED off, then we're going to print to the serial monitor unknown command, and then we'll print whatever was passed into the command string after that. Okay, so now we're going to test our code. And again, the first thing we're going to do is make sure we're connected to the Uno on the correct comm line. We can then upload the project to it. And once that's uploaded, we'll open the serial monitor, making sure that we're set to the correct baud of 9600. It's very important here that we have the serial monitor termination character set to new line. Otherwise, our read string until function won't work. I'm going to bring up the Arduino Uno and show the LED that we'll be controlling. Right, let's try it out. I'm going to send LED on and press enter, and yes, we see the LED turn on and we've printed turning on back to the serial monitor. Okay, let's try LED off now. Lovely, that's turned off the LED and we've printed turning off back to the serial monitor too. Let's try that a few more times. LED on, LED off, LED on again. Lovely. You'll also notice the two LEDs just above the LED we're controlling, and these are marked TX and RX. Those LEDs are also flashing, and this is because they're showing the activity on the serial line. The RX will flash when it receives information from the serial monitor, and the TX flashes when the Arduino is printing the turning on and turning off commands back to the serial monitor. Now let's test our troubleshooting. So I'm just going to send down some random message, and yes, we get unknown command and the random message returned to us. Also, if we were to change our serial monitor termination character to carriage return and send LED on, that's not going to work either. This is because we sent down LED on with the carriage return character appended to the end, and the equals function will not see that as an exact match. But when we send LED on with the new line terminator appended, that gets recognized and removed by the read serial string until function, leaving us with just LED on. This method that I've just shown here will likely be perfectly adequate for most small applications. The problem is that Arduino strings are the absolute devil. They have the potential to ruin a few days of your life if you're not careful. Now, I'm not going to go into too much detail here, as this subject could be a video series all on its own, but a quick explanation is that Arduino strings use a memory type called the heap segment. The heap contains the dynamically allocated memory of the Arduino. Dynamic memory meaning that the size of the string can change. This changing size causes gaps in the memory that can be difficult to fill while still giving you the impression that you have more memory than you think. This leads to all kinds of memory corruption issues that can take a long time to pinpoint. So, better to forget about these Arduino strings altogether and use something called C strings. This is a convention of representing strings as character arrays terminated with a null character, and that's what we'll look at next. Okay, let's clear this script and start a new one. Let's do a quick example of what a C string would actually look like. First, we're going to create a character array with 6 elements. The first 5 elements are going to spell out HELLO, with the final element containing the null character, denoted as \0. And that's it. That's all a C string actually is. So let's do another example. We'll increase the length of the test array to 12 and expand our message to say hello world. Again, the first 11 elements spell out hello world, and the final element is the null character. Let's print this array now. First, we'll need to create a serial class again with a baud of 9600, and then we print the array. And then we just need to add in the main loop. Right, we're just going to make sure that we're actually connected to the Arduino Uno, which we are, and let's upload to it now. Lovely, and once we're uploaded, we can open up the serial monitor, making sure that we're on the correct baud of 9600 here. And yeah, we see hello world printed, and then we also see this little character at the start, which is probably just something left over from the upload process. If you want to see a clean output from that, we can close the serial monitor and reopen it, and we should see just hello world. Perfect. Right, and now we're just going to do a little experiment here just to show you how these C strings work. If we remove the space character here and replace it with the null character and upload that, what we'll expect to see is hello. Yeah, so let's just get it with some clean output here. So we should see just hello. So it only prints as far as the null character. So that also means that the length of the array can be really any size you want. It could be 100 characters, it could be 250 characters. That doesn't really matter. Just as long as the number of characters that you pass into it is not greater than this number. So if we put in 10 characters here, even though this is a 12 character array, then we might start to see some memory corruption issues known as a buffer overrun. Now you might be thinking to yourself, how is this any better than using Arduino strings if I can still corrupt the memory? And the answer to that is that with C strings you have the control over the allocation of the memory, and I'll now show you how to use and control them safely. So let's just clean up what we don't need here, and then we're good to go. Okay, so let's first do a brief run through of the structure of how we're going to build our C strings. In the previous example, we used the termination character \n to know when to stop reading. This time, however, we're going to add an additional character at the beginning of the transmission so that we know when to start building our C string, as well as one at the end to know when the message is finished. The message that we're going to send will look something like this. A start character will use a less than symbol for this, followed by some information, and then an end character. When this message gets sent to the Arduino, it will recognize the start character and then add all the information that follows into our C string. Then when the termination character is found, we append a null character to the end of the array. So taking our earlier example of LED on and LED off, the message that we would send down will look something like this: LED on and LED off. Okay, so let's get started on the actual code then. Right, the first thing we'll do is create our start character, and we'll use the less than symbol for this. This will let us know when we should start building our C string. I have it set to a constant because it shouldn't change during the code, and if I do try to change it, I'll get a compilation error helping me not make that mistake. Then we're going to add another constant character called end character. This will act as our termination character, letting us know when we should stop adding to our C string and do something actionable. We're also going to need to define the size of our C string, and we'll use a constant called max characters for that. If you're not familiar with the unit type uint8_t, it just means it's an unsigned 8-bit integer and is the same value as a byte. Then we're going to create the array to hold the C string, and we'll call this received characters, with a length of max characters, which is 10 in this case. We're also going to need a boolean flag to know if we found the start character, and we'll call that receiving data and initialize it to false. We need another boolean flag to let us know that we've found the end character, and that'll be called data ready, and we'll also initialize that to false. Finally, the last variable we need to declare here is the received character index, and we'll use this to track which element we're on in the C string array. In the setup, we'll keep our serial class as it is, and we're going to do a similar LED on off test here, so we'll set the pin mode of the onboard LED to output. Let's move on to the main loop now. Here, as in our previous example, we're going to query whether the amount of information on the serial buffer is greater than 0 with serial.available. If there is information, then we're going to create a variable called received character, and we'll pass 1 byte of that information to it using serial.read. We're then going to check to see if that received character is the same as the start character. If it is, then we're going to change our receiving data flag to true. Then we're going to use an else if statement to check if we're receiving data and if our received character is not equal to the end character. This is essentially checking that the start character has been found but the end character hasn't, meaning that we should be building a C string in this section here. And so if the above is true, we're now going to start adding to our C string array. We're going to use our received character index variable to know which element to pass our received character into. Once this has been passed, we can increment our received character index by 1. We're now going to check if the received character index is greater than or equal to our max characters value. If it is, we'll set the index to 1 less than max characters, which is the last element of the array. This makes sure that even if we receive a message with more characters than the max characters value, that we don't get a buffer overflow, as we essentially dump those characters here because the last element is reserved for the null character. We're now going to use another else if statement to check if we're receiving data and if the received character is the end character. So this section of code is basically just looking for the termination character and letting us know that we should stop building our C string. Once the end character has been found, we append the null character to the end of the received characters array. This has now completed our C string. We can then set our received character index back to 0 and receiving data to false to be ready for the next message. Also, to let our next section of code know that we've finished receiving data and are ready to take some kind of action, we'll set data ready to true. This will be the last section of code, and it's going to handle and act on the C string that we built. We'll firstly check that the data ready flag is true. If it is true, we'll immediately set it false as we're about to use that information now. Let's use the same LED on, LED off commands that we used in the previous example. This time, however, we're going to use a different way to compare the strings, the strcmp function, which is an abbreviation for string compare. This function returns 0 if both strings are equal, and this is practically the same as the equals function that we used in the previous example, but I wanted to introduce some C standard library functions as we'll be using some more of them in the next video in the series on parsing. So if received characters is equal to LED on, then we're going to print received characters and set the LED high. Then in the next statement, we're going to use the string compare again to compare the received characters with LED off. If they are the same, then the function returns 0, and again we'll print received characters, but this time we'll set the LED low. Finally, we have our troubleshooting, where if received characters was not equal to LED on or LED off, we'll print unknown command followed by whatever was received. Okay, let's test this code out. So we'll just upload it to the Arduino, making sure that we're connected to it first. Lovely. And open up our serial monitor, making sure that we're on 9600. So in this case, the new line doesn't actually matter, so we can have no line ending because our termination character is already predefined in the code here. So if I send down, actually, sorry, I have to put on the overhead view. So now we can see our Arduino Uno, and it's waiting for us to send down LED on. And yes, it's turned on, and now we can do LED off. Perfect. Let's do LED on again. Lovely. And I'll also just show you, I suppose, how the C string works. So if I put in 1, 2, 3, 4, 5, 6, 7, 8, 9, that should print back 1 to 9. So unknown command, fair enough. And then it just says 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 elements in the C string array. The last element in that is the null character. So if I say put in this, and I do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I can just do, you know, a couple more 9s here at the end. If I send that, I should only see 1 to 9. Yeah, and then if we press up, we can get the last command back up. And so, like I was saying, all these here get dumped in this section of code here. So that's what's protecting us from writing more characters to the array than is allowed. That concludes this video on reading information from the serial monitor and doing something useful with it. What we've done here is build a really good foundation for setting up an Arduino or any microcontroller really to execute commands received from the serial monitor. And this is a really good starting point for building more advanced projects. I hope you enjoyed this video and found it useful. Look out for the next video, which should be on parsing. Please comment if you've got any questions or suggestions, and I'll do my best to answer them. And yeah, subscribe for more videos to come.